So let's look at another practice. How many copper atoms are in a penny weighing 3.10 grams? And we're going to assume for the purpose of this exercise that a penny is made up only of copper, although we know that's not true. So the first thing we want to do is write down what we're given, which is 3.10 grams of copper, and what we want, which is the number of copper atoms. And so then we've got to figure out the conversion factors that take us from mass of copper to number of atoms of copper. So let's remember the two possible conversion factors with moles. We can go back and forth between mass and mole and mass using molar mass, and then we can go back and forth between mole and number using Avogadro's number. So let's go ahead and write out our conversion factors. I know that 1 mole of copper atoms is always going to be 6.022 times 10 to the 23 copper atoms. And so now we have a conversion factor that gets us to actual numbers. Now I need a conversion factor that deals with mass. I find copper on the periodic table right here, and its molar mass is 63.55 grams. So 1 mole of copper, we can write atoms here, although typically it's not, is equal to 63.55 grams of copper. Okay, now I have 2 of every unit, 2 grams, 2 moles, and 2 pure numbers of just copper atoms. So I'm ready to start my railroad math. Okay, so I always start out with my given, 3.10 grams of copper. So grams of copper need to go down here. And 63.55 grams of copper, and then 1 mole of copper. So my grams of copper cancel out. I have moles of copper here. I have to have moles of copper down here. And here's the other conversion factor that has moles in it, and 6.022 times 10 to the 23 is the other part. So my moles of copper cancel out, and then I'm going to let my calculator do the math. Remember, we multiply what's on top and then divide by what's on the bottom. Now my calculator tells me 2.937560976 times 10 to the 23. And we'll look at our sig figs in just a second. First, let's see, does this make sense? This is a huge number, and when we're talking about number of atoms or molecules or ions, then yes, we're going to be talking about a huge number. This is less than a mole. A mole, whoops, this is 22. A mole is 6 times 10 to the 23, and a mole is also 63 grams when we're talking about copper. And so this is less than a mole, definitely much less, about an order of magnitude. And so this is less, so that makes sense by an order of magnitude. All right, now let's look at our sig figs. I have 3 sig figs, so here's my last allowable sig fig, the 3. I look to the right, and that's a 7, so my 3 is going to be rounded up. So let's look at how to correctly express my answer. 2.94 times 10 to the 22 copper atoms. Okay, again, we don't want to forget our power of 10. That's critical. We don't just have 2.94 copper atoms. We have 2.94 times 10 to the 22 copper atoms. And this is actually a whole number. This is not a decimal, even though we're expressing it as a decimal in scientific notation. This is a whole number, a huge, huge, huge whole number.